Good afternoon, class. We are looking at Chapter 4, Application of Derivatives. Here's Section 4.6, Antiderivatives. So we looked at maximum and minimum values, how derivatives affect the shape of a graph, optimization problems, and now antiderivatives. Again, various differentiation formulas. Delta y, rise along the curve, versus dy, rise along the tangent line. And linearization, which means just use the point slope to find the equation of a tangent line. So L of x refers to the tangent line, everybody. Now, section 4.6, antiderivatives. Anti-differentiation, integration, they ultimately mean the same thing. Calculus has two parts. Differential calculus, which deals with the instantaneous rate of change and slope of a tangent line. And integral calculus deals with accumulated change and area under a curve. Both parts rely heavily on the concept of a limit, and they are intimately related. Integral is the opposite of a derivative, also called antiderivative. So here's the question. Given the derivative of a function, what is the original function? That is what we are looking for, everybody. All right, anti-differentiation, integration. So anti-differentiation, integration, the antiderivative of f of x, lowercase f of x, is the set of functions, capital F of x plus c, such that d dx of capital F of x plus c is lowercase f of x. The constant c is called the constant of integration. Anti-differentiation is often called integration. To indicate the antiderivative of x squared is x cubed over 3 plus c, we write the integral of x squared dx is x cubed over 3 plus c. This symbol, the symbol of integration, was introduced by Leibniz and is called an integral sign. It is an elongated S. Think about it, S, elongated S, and was chosen because an integral is a limit of sums. In general, the integral of f of x dx equals capital F of x plus c. Capital F of x plus c is the general form of the antiderivative of lowercase f of x. Here's what I want you to pay attention to. When we differentiate, we get one function. When we integrate, we get a family of function, and that's why we have this constant, everybody. Okay? The reason is simple. When you differentiate a number, any constant, the derivative is zero. That's why you get a family of functions. Now, with that being the case, if capital F and G are any two antiderivatives of f, then capital F prime is lowercase f, and capital G prime is lowercase f. If two functions have the same derivative, the two functions are ultimately the same, except they differ by a constant. Therefore, one of them, for example, capital G of x, is the other one, capital F of x plus c, or vice versa. Simply put, the difference between the two is just some number. A simple warm-up example. Determine these indefinite integrals. Okay, they are called general or indefinite integrals. When you have this, just pay attention to 8. What this does, everybody, this tells you the variable you use is x. So think about this, 8. Can anybody tell us what function you differentiate to get 8? Anyone? That would be 8x. So 8x plus a constant. And to check, you differentiate the right side to get to the left side. Remember, when we started learning about division, okay, we would check it with multiplication. Now, what does this mean? Let me write it on the side. If I had 8 dt instead of 8 dx, the answer would be 8t plus c. So I want you to see the importance of dx, also known as the dummy variable. Ten x to the power of 9 dx. We want to take the integral of that. So think about it. There is a function that you differentiate, you get that. What function would that be? Anyone? X to the power of 10 plus c. If you differentiate x to the power of 10, you get 10x to the power of 9. And to check, you just differentiate the right side. And remember, constant gives you 0. The integral of e to the power of x dx, just look at e to the power of x. What do you differentiate to get e to the power of x is itself and a constant, and differentiate the right side, you get e to the power of x. The integral of 1 over x dx, what gives you 1 over x would be natural log, so natural log of x plus c, if you differentiate that, and that's how you check it. Now I'm going to discuss basic integration formulas. The derivative of kx is k. So if that is the case, it means the integral of k dx must be kx plus c. The derivative of x to the power of n is n to the power n x to the power of n minus 1. So the reverse process, see, we are multiplying by n and we subtract 1 from n. The reverse process is to instead of subtracting 1, add 1 and then divide by it. And so we get the integral of x to the power of n dx is x to the power of n plus 1 over n plus 1 plus a constant. Needless to say, the denominator can't be 0. So I'm going to look at this first as far as explanation, and then actually I'm going to differentiate the right side to see that we get the same thing. So with that being the case, d dx of x to the power of n is n x to the power of n minus 1. We know that. So what are we doing? We multiply by n and we subtract 1 from n. Now to integrate this, we go with the reverse process, which means we are going to go this way, which means first we are going to go with the second part. Subtraction becomes addition, add 1. So it becomes n plus 1. And then multiplication becomes division, divide by n plus 1. So that's as far as the process is concerned. The other one is that if you look at the right-hand side, and I'm going to write it as 1 over n plus 1, x to the power of n plus 1, and a constant. So if I want to differentiate this class, I get 1 over n plus 1 times n plus 1, x to the power of n plus 1 minus 1. These two cancel each other. This becomes x to the power of n, and that's exactly what we have here. So I prove that it works, the reverse process. Okay, everybody? Let me erase my work. Let's look at each one. E to the power of x, the answer is e to the power of x. So if I go this route, the integral of e to the power of x dx must be e to the power of x and a constant. Natural log gives me 1 over x. So if I go this route, the integral of 1 over x dx must be natural log and a constant. Now, one thing I want to add, class, 1 over x is the same as x minus 1. I want to go this route. If the derivative of sine is cosine, the integral of cosine x dx must be sine x and a constant. Now, this one I want you to pay attention to. The integral of minus sine x dx is positive cosine x and a constant. So we take the negative to the other side, and we say the integral of sine is minus cosine and a constant. Now, tan gives you secant, so the integral of secant x dx must be tan x and a constant. Cotangent, the derivative, gives you minus cosecant squared. So the integral of cosecant squared dx must be negative cotangent x and a constant. This one, then the integral of secant x tan x dx must be secant x. And the last one, the integral of cosecant x cotangent x must be minus cosecant x times dx, of course. Must be minus cosecant x and a constant. So the reverse process. As far as this one is concerned, whether you differentiate or integrate k, you just keep it outside or in, makes no difference. Sum and difference says you differentiate and integrate term by term. That's the meaning of it. What about this one? When you differentiate e to the power of kx, you get itself times k. So the integral would be the reverse process, meaning you get the same thing, but this time divided by k and a constant. I hope everybody is okay with that. Let's look at a few simple examples, everybody. The integral of x to the power of 7, you add 1 and divide by it, and a constant. So you get 1 over 8, x to the power of 8, and a constant. What about this one? You add 1, you get 100. So 1 over 100, x to the power of 100, and a constant. Now, what about this? As you recall, in the case of differentiation, we had to change it to x to the power of 1/2. Exactly the same thing here. So you add 1 and you divide by it. So 1 over 1/2 plus 1, x to the power of 1/2 plus 1, and a constant. What is 1/2 plus 1? 3/2. And this is 2/3. So 2/3, x to the power of 3/2, and a constant. Whether you differentiate or integrate, in this case, you want to use the power rule, so you have to change it. So this change is the same for differentiation. And now you add 1, you divide by it, and that's the exponents. 1 over minus 3 plus 1, x to the power of minus 3 plus 1, and a constant. Negative 3 and 1 is negative 2. So this is negative 1/2 x to the power of minus 2, and a constant. You take this one down, you make it x to the power of 2. And so the final answer is minus 1 over 2x squared plus a constant. Find the antiderivatives. Remember, exponentials, you differentiate, you integrate, they're the same. Differentiation, you multiply by 4 in this case. Integration, you divide. So the answer is itself. Because you're integrating, you divide by 4, and of course you add a constant. Same thing here. The answer is itself. But you have to divide by negative 3 and add a constant. Division by -3 is the same as writing -1/3. E to the power of x over 2. Well, to make sure we know what we are dealing with, we are going to write x over 2 as 1/2 x, and therefore the answer is itself, and then you divide by 1/2, so 1 over 1/2. 1 over 1/2 is 2, so 2e to the power of x over 2 and a constant. Now, we know the integral of 1 over x dx is ln of absolute value of x plus c. If you recognize this as 2 times 1 over x and you don't want to write it, is fine. But just to be on the safe side, I would write it as 2 times 1 over x. And so I would say the same answer here, just put a 2 in front. And what about this one? I'm going to rewrite it in this manner. And I say, okay, I recognize 1 over x, just the same thing as this one. I put the 1/2 in front. So that's how you deal with those integrations. Exponentials, 1 over x, which results in natural log. All right. Now, you just do this term by term. You ignore everything. You just look at the very first term and you add 1. You get 5. So you get 2 over 5, x to the power of 5. You add 1. You get 4. 3 over 4, x to the power of 4. You add 1. You get 3. Minus 7/3 x cubed with the. Now, this one, I want to make sure you can see that this is x to the power of 1. So 1 over 1 plus 1 x to the power of 1 plus 1. So 1/2 x squared. And of course, if you have a constant, in this case -5, you get -5x plus a constant. The integral of x minus 5 quantity squared. This is following a minus b squared, which is a squared minus 2ab plus b squared, which gives you x squared minus 10x plus 25. So x squared, you add 1, 2 becomes 3, so 1/3 x cubed. This one, just like that one, I'm going to write 1 here, and I'm going to say minus 10 over 1 plus 1 x to the power of 1 plus 1. So that's minus 5x squared. 25 is a constant, so simply 25x plus a constant. And so that's it, everybody.